Today's lesson will cover rational expressions. We'll start by simplifying rational expressions and then move into multiplying and dividing them. First of all, a rational expression has a variable in the denominator. So it's not good enough to think of, let's say, 2/3 x. This is not a rational expression. But 2/3x, yes. So this is just a regular polynomial here, but this would be considered a rational expression because you have a variable in the denominator. And always remember, thou shalt not divide by 0. So at some point, we would have to exactly say x cannot equal 0 in this problem. Okay. A fraction is reduced or simplified when its numerator and denominator have no common factors. So, for example, this fraction needs to be reduced because it has a common factor of c. So now this would be reduced or simplified, whichever you prefer. If you had a fraction like this one, you could factor it first so that you could see the common factors, and now it's considered reduced. In this section, we'll look at polynomials in the numerator and denominator. So what we would do is factor them first, and then you can more readily identify the common factors, and whatever's left, we'll put there. And notice we have to say x cannot equal -3 because -3 makes the denominator equal 0. So our simplified answer would be this, and that would be all. For example 1, let's simplify x squared minus x minus 12 all over x squared minus 9. I've given you a few easy to follow steps. You want to start by factoring the numerator and the denominator. So if we look here, we'll try to factor with a diamond. And so the numerator factors to x minus 4 over x plus 3. And the denominator, that's the difference of two squares. So the square root of x squared is x, and the square root of 9 is 3. So we have our plus minus. And now we can see our common factors and start slashing. A common mistake that students make is they try to cancel these x's. And I say, no way, you cannot do that. Also, we need to say that x cannot equal a +3 because that would make the denominator 0. So anytime you're asked to restrict the domain, that's what they mean for you to do. I just want you to get familiar with that idea of restricting the domain, keeping it in the real numbers. So this would be your final answer. Okay, let's look at one a little more complicated. Let's say we would like to simplify this, and now you can see how very important factoring was for us. So we have to remember how to factor each one of these. So for that numerator, I can first factor out a GCF of 4x cubed, which leaves me with x squared minus 2x minus 24. Yeah, that looks good. And I can do another diamond here. Hopefully you remember how to factor. And so we have 4x cubed, x minus 6, x plus 4 for that part. And then for this one, we want to factor this as well. So to factor that one, we get 8x comes out as a GCF, and we're left with x cubed plus 4x squared minus x minus 4. 4 terms, I'm going to try to factor by grouping so I don't have to do synthetic division. So out of these first two, an x squared comes out, and I have x plus 4 left. Negative 1 comes out, and I have x plus 4. And I'm left with 8x times x squared minus 1 times x plus 4, or 8x, x plus 1, x minus 1. And we still have the x plus 4. So now that we've factored the numerator and the denominator, we can see what factors are in common. And just start reducing. So right away I can see the x plus 4 is in common. Also, I can reduce this. 8 over 4 is 1/2 because 4 is in both of these, and that leaves a 2 down there. And then I have x to the first power, and here that's like x times x times x. So one of those x's will cancel, or you could just say 3 minus 1 is 2. So I'm left with x times x, or x squared, in the numerator. So now if I can read my writing, I have x squared times x minus 6 over 2 times x plus 1, x minus 1. You could definitely leave the answer like this, or if you were so inclined for extra work, you could multiply the denominator back together, but you certainly don't have to do any of that. You could even distribute it in, but I'd like for you to know that as long as there are no common factors in the numerator and denominator, you're done. So this would be a great place to stop. But I wouldn't mark you down if you started multiplying it back together. It's just not necessary. For example 3, let's multiply these two rational function expressions together. So again, of course, we start by factoring. So let's see, this looks pretty easy. 3 comes out, and that leaves me with x squared minus 4. So that's going to be 3 times x plus 2, x minus 2. And in the denominator, that's negative 20, negative 1. So that's 5 and 4, negative over here. So I have x minus 5, x plus 4. And for this one, let's see, that's 10, negative 7, negative 2, negative 5, x minus 2, x minus 5. And over here, 6 comes out, and I have x minus 2. So, at this point, you could just pretend that this is one long fraction, and it's all mushed together. So I have an x minus 5 here and here. 3 goes into 6 twice. X minus 2. And I think that's all I can cancel out. And I'm left with x plus 2 times x minus 2 over 2 times x plus 4. I think I've got everything. Yeah, okay. And so that's a great answer there. Okay. Example 4. Now, when you divide, remember if you want to divide A over B divided by C over D, what you do is you multiply by the reciprocal. You flip the second fraction. Never flip the first one. You only flip the second one. And so you'd get AD over BC. And again, B and C. As a matter of fact, B, C, or D, anything that's been in the denominator at any point cannot equal 0. Okay, so we would have to quantify all of that if you were asked to restrict the domain. But I didn't ask you to do that, so no worries. So let's see, we have 4x to the 6th on top, x plus 5, x minus 2. And now we're going to flip this second fraction. So now, just mushing it all together, I have x minus 1 and 2 minus x and an 8x squared here. Okay, so all I did is flip that second fraction. Now I'm going to see if anything cancels out. Ooh, cute, cute. Warning, warning. We have 2 minus x. How is that different from x minus 2? If we were to distribute a negative sign, that would work. But let me just show you a shortcut, okay? If you want to cancel it out where 1 is backwards, just add a negative 1 to either the top or the bottom, not both. Just if it's backwards, negative 1 is your byproduct. Okay, and let me make sure I explain why that's so. Imagine the difference between 7 minus 3 versus 3 minus 7. One's going to be positive, one's going to be negative. That's the difference. So if you were to have one over the other, when you cancel that, you get 4 over negative 4. It's just going to leave a negative 1, and they'll be canceled. Okay, so same thing here. These are backwards. Just leave a negative 1 and you're good. Okay, now 4 goes into 8 twice, and 6 minus 2 is 4. So this is x to the 4th power. So in the numerator, it appears I'm left with x to the 4th, x minus 1, and I also have this negative 1. I'm just going to put a negative right there. And in the denominator, I have 2 over x plus 5. Let's see, did I get everything? Yep, and all that's canceled out. And up here, I have the x to the 4th. Okay, so that looks like a great answer. And you could leave it just like that. No worries. All righty.